Hello, my students, and welcome to this session. In this session, we're going to talk about logarithmic function and its graph. Before we start, I want to show you an easy example. If we have 3 to the power of 2 equals 9, we can write this using another way. We can write it as logarithm 9 to the base 3 or in the base 3 equals 2. So log 9 in the base 3 means what is the power? We can raise this 3 to it to get 9. This power is 2. So 3 to the power of 2 is 9. We can write it using another way, which is log 9 in the base 3 equals 2. So 2 is the power. And this example, 5 is the base. 5 raised to the power of 3 equals 125. We can write it as log 125 to the base 5. What does it mean? What is the power? We can raise 5 to it to get 125. It's 3. So I'm asking about the power. So when I ask you about log 64 to the base 8, what does it mean? I'm asking about the power. We can raise 8 to it to get 64. This power is 2. Because 8 to the power of 2 equals 64. If we have an example like log 20 to the base 5, I'm asking about the power. We can raise 5 to it to get 20. You know that 5 to the power of 1 is 5, and 5 to the power of 2 is 120, is 25, okay? 5 to the power of 2 is 25. So it's something, the power is something between 1 and 2. We can use the calculator to find this value. Just write log and write here in front of log, write 20. You write here 20 on the calculator and write in the base of 5. You will get the result on the calculator. It's 1.861. 1.861. When we round it, we will get 1.9. So that means 5 raised to the power 1.9 approximately equals what? Equals 20. So what does log mean? Log without any base, if we have log here, so we consider the base as 10. So log only, if we ask about log 100, what is the base? The base here, it's not written, but we deal with it as 10. In this case, it's 10. So log to the base 10 equals what? Equals 2. What about log 1000? Log 1000, it's the base is 10. It's not written, but we deal with it as 10. So it's 10 to the power of 3, because 10 to the power of 3 equals 1000. Now let's answer these questions. Log 8 to the base 2. Log 8 in the base 2 means 2 raised to the power of what equals 8? It's to the power of 3, because 2 to the power of 3 equals 8. So log 8 in the base 2 equals 3. And log 3 to the base 9. Log 3 in the base 9 equals what? You know, 9 is the base equals, this is the number here. So 9 to the power of what? Equals 3. You know that this 9 can be written as 3 to the power of 2 all to the power of x equals 3. So 2 times x, it's 2x, so 3 to the power of 2x equals 3 to the power of 1. Okay, the base equal the base, so the power is equal to the power, so 2x equals 1. That means x equals half. So 3 log 3 to the base 9 equals half, because 9 to the power of half equals 3. What about log 10? In this case, the base is 10, but it's not written. So log 10 to the base 10, it's 1. Log 10 in the base 10 equals 1. So what about log 1? Log 1 in the base 10 here. So 10 to the power of what equals 1? 10 to the power of 0 equals 1. So log 1 in the base 10 equals what? Equals 0. What about log 12 in the base 3? You know that 3 to the power of 2 is 9. And 3 to the power of 3 equals 27. But in this case, we are going to use the calculator to find it. So you write on the calculator log 12 in the base 3 equals, you will find the answer as 2.26. We can approximate it to the nearest one decimal place. It will be 2.3. Log n in the base a equals x, means a to the power of x equals n. N is the number, a is the base, and x is the power. So n, the number, equals the base raised to the power of x. What about log a in the base a? This is the number, and this is the base. So a raised to the power of what equals a is 1. So log a in the base a equals 1, like log 8 in the base 8 equals 1. What about log 1 in the base a? It's 0. Why is that? Because any base here, like a except 0, raised to the power of 0 equals 1. Like log 1 in the base 8. 8 raised to the power of what equals 1? It's 0. Now let's go to the multiplication rule. If I assumed that log x to the base a equals b, log x to the base a equals b, so we can write it as a to the power of b equals x, because here is the base, here is the base, and b is the power. And if we have log y to the power of a equals q, so that means a to the power of q the same, equals y, the number. So a to the power of q equals y. So xy equals what? Xy, because x is a to the power of b and y is a to the power of q, so we can multiply them. So xy equals a to the power of b times a to the power of q. When multiplying like bases, we add powers. So it's a to the power of p plus q. So xy equals a to the power of b plus q. xy, we are going to deal with it as the number. Xy is the number, and a is the base, and p plus q is the power. So we can write it in the logarithmic way, which is log the number, log xy, in the base a, the base is a, equals p plus q, equals p plus q. So log xy in the base a, instead of b, you will write the value of b. I assume at the very beginning, b is log x in the base a. So write p as log x in the base a plus log y in the base a. Okay. So example about that. If we have log 20 to the base 3 plus log, let's say 4 in the base 3, we can write it as log and multiply 20 times 4. It's 20 times 4, okay, in the base 3. So it's log 80 in the base 3. So log xy in the base a is the same as log x in the base a plus log y in the base a. Remember, I assumed that log x in the base a, it's p, and log y in the base a, it's q. What if we divided x by y? Let's do it. When dividing x over y, here, x divided by y. So we need to find the value of x and we need to find the value of y. Let's go to the log x in the base a equals b. So b is the number, okay, equals, b is the power, sorry, equals the base here. The base here is a and the power is b and the number is x. So x equals a to the power of b. And here, y is the number, and the base is a, the power is q. So y equals a to the power of q. So let's divide them, x divided by y. So x divided by y is going to be a raised to the power of b divided by a raised to the power of q. So x divided by y equals, we can write it as a and subtract powers. It's b minus q. And this is the number, x over y is the number here. And a is the base, a is the base. And b minus q is the power. So we're going to write them in the log way. So log the number, log x over y, this is the number. Okay. In the base, a equals p minus q. Let's substitute p instead of b. You are going to write log x in the base a minus q. Q is log y in the base a. So we reach to a conclusion, which is the division rule. So log x divided by y equals log x in the base a minus log y in the base a. That's it. So we have studied till now the multiplication rule. Let's have a look at it. The multiplication rule, log x times y in the base a equals log x in the base a plus log y in the base a. And also we have studied the division rule. Log x divided by y is the same as log x in the base a minus log y in the base a. If we want to find log x raised to the power of n in the base a, what is the meaning of x raised to the power of n? It's x multiplied by itself n times, like log x times x times x times x multiplied by itself n times in the base a. And from the previous rule, the multiplication rule, we have x multiplied by x multiplied by x, all of them in the base a. So we can write them as log x in the base a plus log x in the base a plus log x in the base a n times. So we have the same log multiplied by itself n times. We can write it as n log x in the base a. So log 5 to the power of 3 in the base 2. We can write it as 3 log 5 in the base 2. Okay. Let's answer some questions about these rules. Simplify. Log 4 in the base 3 plus log 5 in the base 3. So here is the multiplication rule. We can write them as log and multiply 4 times 5 in the base 3. So it's log 20 in the base 3. The next one, it's the division rule. And we have the same base here, it's a 2. So we're going to try to log and write 72 divided by 9 in the base 2. So it's log 72 divided by 9, it's 8 in the base 2. And 8 is the same as 2 raised to the power of what? We can answer it, it's 3. What about the next one? Here we have 2 log 5. So 2 log 5, we can write it as log 5 to the power of 2. Okay, if you remember, log 5 to the power of 2 is the same as 2 log 5 plus log 4. So log 5 to the power of 2, it's log 25 plus log 4. Okay, and here we can use the multiplication rule. It's log, you multiply 25 times 4. 25 times 4 in the base 10. It's not written, but we deal with it as 10. So it's log 100 in the base 10. So equals what? Equals 2. The next one here, I have log, I want to expand here. I want to expand. So log x to the power of 3, y to the power of 2 divided by z. It's the same as log x to the power of 3 here plus, because it's times, plus log y to the power of 2, and then we have divided by z, so minus log z. The next, we have log x to the power of 3, so it's going to be written as 3 log x plus, here we have log y to the power of 2, it's 2 log y minus log z. Okay, this is the expanding of this one here. Let's go to an important rule. If we have log n, this is the number, and the base a equals x. So from that, the base raised to the power of x equals n. Okay. And if we have log a to the power of x in the base b, we can apply the power rule, which is x multiplied by, we will move this x here, the power x, this power, multiplied by log a in the base b. This is an equation. From that, we can find the value of x by dividing both sides, by log a in the base b here and here, by dividing here by log a in the base b here and here. So cancel them out. And here you will end up with x equals log a to the power of x in the base b divided by log a in the base b. And we have the value of x, you know, you have the value of a to the power of x here. What is the value of a to the power of x? The value of a to the power of x is n. So we are going to pass it here. Instead of, so x equals log n, instead of a to the power of x in the base b over log a in the base b. And what is x? X is log n in the base a. X, we can substitute the value of x. Okay. Instead of x, you are going to write log n. Okay, because x equals log n in the base a. So log n in the base a equals log n in the base b over log a in the base b. What is that? This is the change of the base rule. This is the change base rule. So log n in the base a. Let's take an easy example about that. So log n in the base a, let's write log 20 in the base 3 equals. We can write it as log 20 in any base. We can take any base like the base 2 over log 3 in the base 2, like this rule here. We have here log n in the base a. We wrote it as log n in the base b, any base, over log a in the base b. So b is any base we can write. B is any base. And from that, if we have log 3 in the base 2, we can write it as log 3 in the base 3 over log 2 in the base 3. Okay, and log 3 in the base 3 is 1 over log 2 in the base 3. What is that? This is the inverse rule. So log 3 in the base 2, we can write it as 1 over log 2 in the base 3. So we reach to an important conclusion, which is log a in the base b equals 1 over log b in the base a. That's it. So if we have log n in the base a, we can write it as log n in the base b over log a in the base b. Like this example here. Log 32 in the base 8. We can write it as log 32 in the base 2 over log 8 in the base 2. And log 32 in the base 2, 2 raised to the power of what equal 32? It's 5 here. Over log 8 in the base 2. 2 raised to the power of what equals 8? It's 2 to the power of 3. So right here 3. So it's going to be 5 over 3, which is 1 and 2/3. Simplify log 5 plus 3 over 5 log 32 minus log 4. That is equal to log 5 here. Okay, plus we have this number multiplied by log, so we can write it as a power. So it's going to be log 32 raised to the power of 3 over 5 minus log 4. That is equal to what? We have here log 5 plus 32 to the power of 3 over 5. You know 32 to the power of 3 over 5. 32 can be written as 2 to the power of 5, all raised to the power of 3 over 5. Multiply them. So 2 to the power of 3 equals 8. So plus log 8 minus log 4 equals log. We will apply the multiplication rule. We have 5 here, log 5 plus log 8 minus. We have minus. So minus means you are going to multiply the division rule. So it's log 5 times 8, and all of that divided by 4. So it's log 5 times 8, 40 divided by 4, it's 10. So log 10 equals 1. Express the following in terms of log x and log y. I have log square root of x to the power of 2 divided by 5y to the power of 2. We can write it as log here. And we have the square root of this expression. So write it as x squared over 5y to the power of 2, all raised to the power of half. What about this power here? We can write this power here in front of the log. The power rule, it's a half multiplied by log this expression here, x squared over 5y squared. So it's half here. And this, look here, we have x power of 2. So it's divided by 5y to the power of 2. We can write it as log x power of 2 minus log 5y to the power of 2. Okay. What is the next step? Leave this half as it. What about this power here, 2 above x? We will write it as 2 multiplied by what? Multiplied by log x minus. We have here 5 multiplied by y to the power of 2. So it's log 5 here plus log y to the power of 2, because the question is to write them as log x and log y only. So we have here y to the power of 2. I want to write it as y. So 5y to the power of 2, they are multiplying. So I wrote them as log 5 and log y to the power of 2. I split 5y to the power of 2 as 5 and y to the power of 2. What is the next? It's a half. And here we have 2 log x minus, we have here log 5 as it. And what about log y to the power of 2 is going to be what? 2 log y. I have finished it because we are going to leave this half as it here. And we have between the brackets, 2 log x, it's a 2 log x, write it as it. And this minus is going to multiply all terms here. It's negative log 5 and negative 2 log y. That's it. What about log 81 divided by log 27 without using the calculator? You know, the base here is 10 and the base here is 10. It's not written, but we know it. It's hard to find the value 10 raised to the power of what equals 81 exactly. And also 27, 10 raised to the power of what is 27? It's hard to find the exact value. So we will try it 81 as 3 to the power of 4. It's log 3 to the power of 4. And we are going to try 27 as log 3 to the power of 3. And we will apply the power rule. We'll write it as 4 multiplied by log 3 over 3 multiplied by log 3. Then we are going to cancel them out here. Cancel log 3 and log 3. So it will be 4 over 3. I want to get the value of x here in this equation. 3 raised to the power of x is 12. How can we get the value of x? We can use the calculator directly to find the value of x because 3 is the base, x is the power, and 12 is the number. Okay, so log the number, log 12 to the base 3, and the base 3 equals x. We can use the calculator to find x directly. It's log 12 in the base 3. Or we can take logs for both sides. Like here, I have 3 to the power of x equals 12. So we can take log here and log here. So it's log 3 to the power of x equals log 12. And I have here 3 to the power of x, so we'll apply the power rule. X log 3 equals log 12. So what is the value of x? X equals what? X equals log 12 over log 3. That's it. So use your calculator to find the value of x. X, it's 2.26 here by using the calculator. What if I have 3 to the power of 2x minus 1 minus 4 to the power of x plus 3 equals 0, and I want to get the value of x. So write it as 3 to the power of 2x minus 1 equals, move it to the next side, equals 4 to the power of x plus 3. What is the next step? The next step you are going to take log for both sides. So it's going to be log 3 to the power of 2x minus 1 equals log 4 to the power of x plus 3. And we will apply the power rule. The power here is 2x minus 1 and the power here is x plus 3. So write it as 2x minus 1 multiplied by log 3 here equals x plus 3 multiplied by log 4. What is the next? You will expand here. It's 2x multiplied by log 3 and minus log 3. So it's 2x, okay, log 3 minus log 3 equals here x plus 3 multiplied by log 4 is going to be x expanded again, x log 4, okay, and 3 plus 3 log 4. Then collect like terms with x. I have here 2x log 3 and I have here x log 4. So move it to the next side. Move it to the next side. It will be 2x log 3 minus x log 4 equals. We have here 3 log 4 as it, and you are going to move it to the next side. Negative log 3, it will be plus log 3. After that, you are going to take x here as a factor. We have x here. So take x here as a factor. You are left with 2 log 3 minus log 4 equals 3 log 4 plus log 3. What is the next step? To find x, divide by this expression here, which is 2 log 3, this value, minus log 4. So what is the value of x? Let's write it here in this room. We don't have much area. So x is going to be what? X is going to be what? Here, to find the value x is going to be 3 log 4 plus log 3 over 2 log 3 minus log 4. Use your calculator, write on the calculator the value of 3 log 4 plus log 3 over 2 log 3 minus log 4. So x is going to be 6.48. To the nearest one decimal place, it will be 6.5. That's it. I want to get the value of x here in this example. I have 3 plus log 2x minus 5 in the base 2 equals log 5x plus 4 in the base 2. So we can move it to the next side. It's going to be 3. So 3 equals log 5x plus 4 in the base 2 minus log, here we have 2x minus 5 in the base 2. Because they are like bases here. We have the base here is 2 and the base here is 2. And we have minus here. So we can write them as 3 equals log. We'll write here the base 2 and we are going to divide the two expressions here. So you will divide 5x plus 4 divided by 2x minus 5. And then we will use the rule, the first rule we have studied. This is the base here. And this is the number. The number is this expression, which is 5x plus 4 over 2x minus 5. And this is the power. Again, this is the power here. And 2 is the base. And here the number. So write the number, which is 5x plus 4 over 2x minus 5 equals the base, it's 2 raised to the power of 3. And 2 to the power of 3 is 8. So 5x plus 4 over 2x minus 5 equals 8. 8 is 8 over 1. Do cross multiplying. So it will be 16x minus 40 here equals 5x plus 4. What is the next step? Move 5x to the next side. So it's going to be 16x minus 5x equals 4 plus 40 here. I moved it to the next side. 16x minus 5x, so it's 11x equals 44, divided by 11 both sides, so x equals 4. That's it. If we looked at this example here, we have log 4 in the base 9. The base here is 9. Okay. Plus log x, the base here in 3, in the base 3. We couldn't use the multiplication rule because the two bases are different. But we can write this one here as log 4 in the base 3 over log 9 in the base 3. Why 3 exactly? Because the base here is 3 and the base here is 9. And here we have log x, so the variable here in this log, and its base is 3. So I wrote log 4 in the base 9 as log 4 in the base 3 over log 9 in the base 3. And as you know, log 9 in the base 3 is 2. And you'll complete writing the question here. But in this one here, it will be log 4 in the base 3 over 2. Because log 9, as you know, log 9 in the base 3 equals 2. 3 raised to the power of what is 9? 3 raised to the power of 2. Plus log x in the base 3 equals 3. Okay. Multiply all terms by 2 to cancel this 2 here, which is written down. This 2 here. So multiply all terms of the equation by 2. Multiply the first one by 2 here to cancel this 2, and multiply here by 2 here and by 2 here. Okay. So cancel 2 and 2. You will end up with log 4. Log 4 in the base 3 equals, plus 2 log x in the base 3, which is log x to the power of 2 in the base 3. This 2 here moved as a power above x equals 3 times 2, which is 6. Now we can apply the multiplication rule because the base here is 3 and the base here is 3. So we can write log in the base 3, and you'll multiply log here, you'll multiply 4 by x to the power of 2. So it's 4x to the power of 2 equals 6. What is the next step? The next step, you will apply the first rule we have learned. This is the base, and here is the number, and here is the power. So 4x to the power of 2 is going to be equal to 3, the base raised to the power of 6. And to get this x to the power of 2, you will divide the 3 to the power of 6 divided by 4 by using the calculator. 3 to the power of 6 divided by 4 is going to be, or we can find the square root directly. It's x equal the square root of 3 to the power of 6, which is 3 to the power of 3. It's 27 over 2. So what is the value of x? Is 27 over 2. When it comes to graphing the logarithm function, so first of all, we can graph 3 to the power of x by taking some values. Okay, and this value, this function is increasing on x. So 3 to the power of 0 is 1 here, and 3 to the power of 1 is 3, and 3 to the power of 2 is 9, 3 to the power of 3 is 27, and 3 to the power of negative 1, it's negative third, and 3 to the power of negative 2, it's 1 over 9. So as you see here, you will find the curve going up here, and this curve doesn't touch x-axis. It approaches x-axis. This is the function 3 to the power of x. You know, 3 is the base and x is the power. And this function crosses y-axis at the point 0 and 1. And if you tried to graph log x in the base 3. So here, this is log x in the base 3. By taking some values, we can take some values, but log 1 in the base 3, 1 is 3 to the power of what? 1 is 3 to the power of 0. So this graph crosses x-axis at the point 1 and 0 here. 1 and 0. And if we took value like 3, you will find it's 1 here. And if you took value like 9, log 9, so it will be 2. So you will find a curve is going up here. And when taking some values here between 0 and 1, you will find this curve is going down here. This is the graph of log x in the base 3. And this function is the inverse function of 3 to the power of x. So if you have a function like f of x, 5 to the power of x, what is the inverse function of this function? The inverse function of this function is going to be log, okay, x in the base 5. Okay, that's it. And this function is reflected in the line y equals x. So the logarithmic function is the inverse function of the exponential function. And the two curves of the two functions are symmetric about the straight line y equals x. The domain of the exponential function is R. And the range of the exponential function is 0 and positive infinity. The domain is R, and the range is 0 and positive infinity. Okay, and the domain of the logarithmic function, is 0 and positive infinity. This is the domain, 0 and positive infinity. And its range, the range is R. I hope you enjoyed this session. See you in the coming episodes. Goodbye.